All right, let's do something incredible. Today, we're taking a journey, a cosmic zoom out, from our tiny home here on Earth all the way to the absolute edge of everything we can possibly see. It's going to be a wild ride, so let's jump right in.
So every great journey has a starting point, right? And this is ours. This is home base. Before we blast off into the mind-boggling scales of the cosmos, we've got to ground ourselves right here, in the familiar.
I just love this quote because it gets to the heart of it. This isn't just some far-off, abstract thing we're looking at. You, me, we're literally part of it. We're not just in the universe, we are the universe, experiencing itself. We're made of stardust, looking back at where we came from.
Okay, so to really feel the scale of this trip, we need to know our address. Not our street address, but our cosmic address. Let's figure out exactly where here is. Starting from our beautiful blue marble Earth, let's pull back. Whoosh! Past our neighboring planets in the solar system. And we keep going, out past the icy frontier of our system, until our own sun is just one tiny point of light inside our home galaxy, the spectacular, sprawling spiral of the Milky Way. So just how big is our galactic home? Well, astronomers estimate that the Milky Way has at least 100 billion stars. Let that sink in for a second. 100 billion suns, and a huge number of them probably have their own families of planets. But, that's just our neighborhood.
Because if we zoom out even further, the numbers just get astronomical. They think there could be up to 2 trillion other galaxies in the universe that we can see. Each one is its own island in space, filled with billions of its own stars. It's just staggering.
Yeah, trying to wrap your head around a number like 2 trillion is basically impossible. So try this. Picture every single beach, on every continent, on the entire planet. Now imagine you could count every grain of sand on all those beaches. There are more stars in the sky than that. It's absolutely mind-blowing. So, with these trillions of galaxies, you might wonder, are they just scattered around randomly, like dust? Well, the answer is no. There's an order to it, a magnificent structure. But to see it, we need to make a map in 3 dimensions.
And this is the huge challenge, right? When you and I look up at the night sky, it's just a beautiful, flat image. A star that's relatively close can look like it's right next to a galaxy that's millions of light years away. So how on earth do they figure out the distance?
The secret weapon is a phenomenon called redshift. It's actually genius. The universe is expanding, and as it expands, it literally stretches the light that's traveling through it. So light from a galaxy that's super far away has been traveling for a long time, which means it's been stretched a lot. That stretching shifts the light towards the red end of the spectrum. So the rule is simple. The redder it looks, the farther away it is. It's the universe's own cosmic yardstick.
And using this redshift yardstick, we can finally start to sort everything out. The galaxies closer to us appear bluer, and we can see all sorts of them, like faint spirals. But as we look deeper and deeper into space, into the past, the galaxies that are far away, well, they appear much redder to us. This is how we take that flat photo and give it real depth. And when you plot all of those galaxies in 3D using their redshift, well, this is what you get. It's breathtaking. An intricate, glowing structure called the cosmic web. You see these dense knots, which are massive superclusters of galaxies, all connected by these long, glowing threads of galaxies we call filaments. And in between, these huge, dark, almost empty regions called voids.
Okay, we've mapped the galaxies. We've seen this incredible cosmic web. But our journey isn't done. We have to keep going. We have to ask, what happens if we look beyond the farthest galaxies?
So now we are really pushing the limits. We are looking so far out into space that we are literally looking back in time, all the way back to the dawn of the universe itself. So what is there? What do we actually see?
We see this faint, uniform glow that comes at us from every single direction in the sky. It's called the cosmic microwave background, and it is quite literally the afterglow of the Big Bang. It's the universe's baby picture, the very first light that could finally travel freely through space, from when the cosmos was just a toddler. And looking at this ancient light reveals a huge puzzle. You see, the early universe shown in this picture was incredibly, almost perfectly smooth. The little differences in temperature were tiny, like 1 part in 100,000. So, how did we get from that smooth soup to the lumpy, structured, web-like universe we have today? Well, the answer, in the brilliantly simple words of cosmologist Jim Peebles, is that gravity sucks. Over billions and billions of years, gravity took those teeny-tiny spots that were just a little bit denser and started pulling more and more stuff towards them. That relentless pull is what built everything. Every star, every galaxy, every cluster in the entire cosmic web.
But here's the twist in the story. Our model of the universe, from the first flash of light to today, it all works perfectly, but there's a catch. And it's a big one. The whole thing only works if you accept that most of the universe is made of stuff we can't see at all.
I mean, really think about this. Everything we've been talking about, all the stars, all the galaxies, every planet, you, me, everything we've ever seen or touched makes up less than 5% of the universe. The other 95% is a total and complete mystery.
And this mysterious 95% seems to be made of two things. About 27% of it is something we call dark matter. It's this invisible stuff that provides the extra gravitational glue that holds galaxies and the whole cosmic web together. The other 68% is even weirder. Dark energy, a mysterious pressure that's actually causing the expansion of the universe to accelerate, to speed up. We know they're there, but we have no clue what they actually are.
Which brings us to the final stop on our cosmic tour. We've traveled from our planet, out through the cosmic web, back to the dawn of light, and right into the heart of a giant cosmic mystery. And now, we've arrived at the very edge of what it is possible for us to see.
Now, this edge isn't like a wall you could run into, it's a horizon in time. See, the universe is about 13.8 billion years old. That means light from any object farther away than that simply has not had enough time to reach us yet. We can't see past it because we can't see further back in time than the very beginning.
So, how big is our bubble of observation? You might think it's 13.8 billion light-years in every direction, but you have to remember that the universe has been expanding that entire time the light was traveling to us. When you factor in all that expansion, the current diameter of the universe we can see is a truly mind-shattering 93 billion light-years across.
And so, this is where our journey ends, at the absolute limit of our vision. We've seen our entire cosmic history unfold. But it leaves us with the biggest question of all. What lies beyond that edge? Is it just more of the same? More cosmic webs stretching on into infinity? Or is there something else out there? Something entirely different waiting in that vast, unseeable expanse? The honest, and maybe the most exciting answer, is we just don't know.